our meetup today. I hope everyone can hear me okay, and we're broadcasting live on over to people all over the world, and we've got our meetup going. Today we're going to be spending some time talking about RancherOS, hopefully giving everyone an introduction and an overview to the product, to what we're doing, to why we built it, and what we think it's good for. We're going to be spending a lot of time, demoing and showing software, and hopefully answering, lots and lots of questions about Rancher and about RancherOS and about why we built this. So just a couple housekeeping items before we get started. I'm Shannon. I'm one of the co-founders here at Rancher Labs. I run our marketing and field activities. You can tell I'm not an engineer because I have a LinkedIn address below instead of a GitHub, or as Darren has a Freenode connection. But one of the we're going to be talking today about really two things. We're going to be talking about kind of why we built this product and what we think it's good for, and we're going to talk about quite a lot about how to actually use it. So we've kind of split up our conversations into me doing the boring overview slides and Darren doing all the fun demo stuff. So Darren is actually in England today, so he's joining us from England. Hopefully we don't have any technical issues. But Darren, you want to say hi? Darren, are you muted maybe? I can't hear you. All right, Darren, I still can't hear you. So if you're talking, you're cutting out, or you're offline. Try one more time. Darren, are you there? All right. Well, hopefully Darren will get back in a second, and when he does, he will chirp in and tell us what happened with his audio and why we can't hear him. But in the meantime, I wanted to just sort of talk a little bit about the format we're going to try and use today to talk about RancherOS and what we're doing. I mean, the biggest thing is I've spent years now working in technology, and I have to say one of my least favorite things are webinars and online presentations, because they tend to be incredibly boring. So when we started to do this, my only goal was to make sure that today was a meetup and not a webinar. I did not want to spend an hour talking to myself and going through a lot of slides where there was no opportunity for people to get involved and ask questions and come up with either really excited, awesome things to say about what we're doing, or kind of pointed questions about why anyone would ever want to do this in the first place. So today is going to be a meetup, and to make that possible, we really need everyone to sort of get involved. And this is the first time we're trying to do an online meetup using GoToWebinar. So hopefully, despite the name, the product will work perfectly as a tool for doing meetups. The idea we have for this, though, is that if it's a meetup, it's got to be more like a real in-person meetup. If any of you have been to meetups, Darren and I spend a lot of time going to meetups, and so do some of the other people here, because they're great opportunities to talk about new technology, showcase stuff that's still under development, get real feedback from people about why it makes sense or why it doesn't make sense, and go deeper into products and requirements. So if it's a meetup, there's got to be some basic ground rules. The first one is questions are really welcome, and the technology is okay for asking questions. Unfortunately, it's nothing like a real room where you could just raise your hand and I'd immediately see it and could stop talking and then ask you to ask a question. But we've got little hand-raising buttons over on the side, if you notice, in GoToMeeting, so you can try to use those. Or if there's also a questions area at the bottom where you can type in a question, and if you type it in, we will see it as we go through and and have a chance to come back to you later and ask any questions. So questions are welcome, and more importantly, tough questions are also welcome. So don't worry about asking tough questions like, why would anyone want to do this, or isn't your competitor way better, or this doesn't make any sense. It's all good. It's a meetup. You're welcome to ask as interesting or tough or leading question as you would like. So please feel free, and we're certainly going to encourage that. The other big thing is, it's a meetup. It's not it's really not meant to be a presentation at a conference. So we're going to do a lot of demoing, and then we're going to demo some more. So we're going to demo as much as possible, and show you stuff that's available now, show you a few things that probably won't be in the product for another couple of weeks as we're still sort of working on UI and finishing up QA. So we're going to be doing a lot of demoing, and and everything we show you, is going to be pretty early. Rancher Labs was only started back in in the fall of last year. We've been working on our products and tools now for the last 6 to 8 months or so. But this is all rough stuff. It's all alpha level software. So don't worry if if something doesn't make sense or you have some questions. It's all being worked on, and we're kind of continually trying to make it better. So great times to ask questions and push back. And then and this is just try not to be overly slidey. We're going to try and keep the slides to a minimum, hit points, try and make things a little more clear, especially about things like architecture. And then hopefully we'll, like any good meetup, we'll be able to give away some stuff with our logo on it. So that is the goal, and leave you with an idea of where we're at and where we're going with these tools and how to get involved. So we'll talk a little bit about that at the end. I'm going to check and see if Darren is audioed in now. Darren, can you hear me? Are you online?
Shannon, I'm here. Can you hear me?
Yes. Okay. I can hear you. Right. You're not muted. Oh, this is going to be really bad. I'm so glad you're here, because let's be honest. If I had to do the demo, it was going to be ugly.
All right.
Oh, all right, great. So now I feel so much better. All my tension is now relieved. So this will be a better webinar. Oh, wait a minute, a better meetup for sure. Okay, so agenda. We're going to cover a number of things today, and try to sort of show you something, kind of explain it in a slide or two, and then jump into a demo to actually show you how it works, and then ask them for questions. And once we've got questions done, we'll sort of move on to the next stage. So I'll start by giving a little bit of an overview of RancherOS, what it is, sort of how it's built, why we built it, what we were thinking when we did it, how it compares to all the other things that are out there that are you can use to run Docker. Then Darren's going to go through a demo, and he'll talk about installing it and setting up, an environment, upgrading, from one version to another. We'll talk about system services and what those are and how to manage them, how to manage them on RancherOS. And, we'll show you all of these things and a whole bunch of different console windows, and hopefully it will all make sense. Once we're done with that and we've kind of explained RancherOS and how it works and what it's useful for, we'll talk about managing it and sort of starting to scale it out. How RancherOS works with Rancher, and what the implications of sort of building a management stack on top of RancherOS looks like. We'll actually go through and show you that then, and deploy a couple, deploy an advanced application, show you how things like Docker Machine work and Docker Compose work, and Darren will go through all that. And once we're done, we'll kind of come back, answer any remaining questions, and then kind of show you if you want to get involved in the project, how to do that. If you want to download it and try it out in your lab, how to do that. And we'll definitely be giving you hopefully a good idea of what to do as part of a big open source project, because that's, to begin with, that's what everything we build is here at Rancher Labs. We build open source software. So everything we do is done out in the in GitHub. We track our bugs there. We issue our pull requests there. We add new code every day, and we're always welcoming other people that want to get involved or have ideas. So this is open source software, and I'll I'm happy to explain that or answer any questions that you might have about that. So let's get started. Obviously, everyone who's registered for this has at least heard of RancherOS, so I hopefully, this won't come as any surprise to you, but RancherOS is a micro Linux distribution that is designed specifically to run Docker containers. We announced it about a month ago now, or maybe 5 weeks ago, and it is, we've had a great response from people, and it's certainly something we're very excited about as a team. But not surprisingly, probably the two most common things we hear are, are kind of like, wait a minute, doesn't Docker run on any Linux? Why do I need a special Linux to run Docker? And probably even more commonly, isn't CoreOS a micro Linux distribution specifically designed to run Docker? So, since I think these are probably very valid questions, I figured I'd just ask them at the beginning and get us going on this. So the first one, doesn't Docker run on any Linux? Yeah, it does. Docker, I think that's what makes Docker so awesome, is Docker runs pretty much on any modern Linux distribution. You can run it on Debian, you can run it on CentOS, you can run it on Red Hat and Fedora, and certainly CoreOS and Ubuntu Snappy and Red Hat Atomic and all sorts of other small micro distributions. But among those, what makes Docker so interesting is that within a Docker container you can package up all your dependencies, which does mean that you don't need as much in the base OS. And because of that, CoreOS, which is a very rapidly growing in popularity micro distribution of Linux, has become really popular for running Docker. Because it basically removes a lot of the excess packages that you don't need to run containers, and when you're going to run them in the container anyways, and put those packages there. So yes and yes, Docker runs anywhere, and CoreOS is definitely has grown in a lot of popularity because it provides a very nice small package that is good for running Docker. And so it kind of then begs the question, so okay, that's all good. Why do we need a new Linux distribution for Docker? Why is something else required or even desirable? Aren't we fine where we are? And so we certainly, when we started Rancher Labs, I don't think we set out with the vision that we were going to go build a new Linux distribution. Historically, Darren and I and Shen Liang and Will Chan, our other founders, we're all infrastructure guys. We all worked on clouds for the last 6-7 years, building clouds at lots of different companies and working with them on on tools like CloudStack, and we really thought Docker provided this really interesting new abstraction that would allow you to take virtualization and take cloud computing to another level of really cross infrastructure computing. And so we started out as big users of CoreOS and other minimalist distributions of Linux. But as we did this, I think the more we worked with Docker, the more excited we got about what the potential was for Dockerizing operating system, Dockerizing Linux. And what we realized as we worked on this was that if you took Docker, or you took Linux, I should say, and you reduced it down to really just what was necessary to run containers, you would be able to build a very small distribution that would have a lot of benefits for portability and for running in space-constrained locations, where you only put in exactly what was required for running Linux. And this is very different than most minimalist operating systems. Most minimalist operating systems include really a full Linux distribution with all the packages you would normally see for regular things. So if a full-sized distro is maybe 2 to 4 gigabytes of capacity, and everything distro is maybe 10. Something like a minimalist distro is usually in the 200 to maybe 400 megs of size, because it's a regular Linux distro. You can boot anything on it. With RancherOS, by Dockerizing the operating system, we could get it down to incredibly small size, where it really did just provide a platform for running containers. And the advantage of this, the advantage of all of these minimalist, smaller operating system is less footprint that needs to be patched and maintained and monitored and managed, a simpler, cleaner architecture that does just what you need it to do. So there's benefits in that, but I don't think that would be enough for us to say, let's go build RancherOS. The really interesting thing is, as we started thinking about what if all of the components of an operating system could be turned into Docker containers, and we could upgrade them using Docker and using simple Docker upgrade like commands. What if we could upgrade an operating system using Docker and Docker upgrade? That would make it possible to not just go from sort of one version to the next version and make it difficult, but rather you could have almost infinite flexibility in moving between versions of an operating system whenever it was appropriate for your organization. You could jump around. You could pick to go back if it made it easier. Everything would then be packaged and delivered as containers. The other thing it would make is modifying an operating system, really as easy as issuing a Docker run command. So if you wanted to, add services or add drivers or add capabilities or add monitoring agents or sort of modify the system, you would just spin up a container, or container and whatever other dependent containers it might have, and that would add new capabilities and services to the operating system. So that started to get really interesting, right? Your operating system was now a collection of containers that could be sort of swapped in and out, and you could swap the console, or you could swap, the syslog system for something you might prefer. You could even potentially swap kernels. Something we've been hearing a lot of people say once they heard of RancherOS, like, wow, what if I could swap to a kernel to improve performance? Is that possible? And the short answer is yeah. The more because the console can be fully isolated from the kernel. We can you can use whatever console you like with whatever kernel you like, and it starts to open up the possibility for effectively a Linux that could be defined with a Docker Compose template. So the fingerprint of your Linux was exactly what you needed it to be, and so. The more we thought about these benefits and what a Dockerized operating system would look like, the more we thought this could be really cool, and it could add a lot of benefit for for certain use cases. And so, yes, there are lots of places you can run Docker, and yes, there's even really small operating systems that run Docker. But what makes RancherOS very unique is it's a very different architecture, a very different approach to managing system services and managing the actual relationship between the user space, the system space, and the kernel itself. And you can sort of see that in the architecture. What makes, kind of defines RancherOS is that on top of the Linux kernel, we run Docker as PID1, as the first process that gets booted when the machine turns on. And Docker is what we use to spin up all of the different system services that are necessary to run the system. So we spin up things like the console and UDEV, and they're all spun up as containers. The other thing that makes it very unique is we then, within that space, we run a second Docker container that is used to run the actual user container. So we call that user Docker. And user Docker is where the applications get deployed. It's where you run your databases or anything you're actually running as a workload on the system. And that allows you to really isolate system processes and system services from the user space, so that when a user kills a container, or kills all containers, they don't go and kill some of these system services and things that are running. So this is what we've built, and as we've rolled this out to people, we've gotten a lot of excitement over really simple ideas like turning on system services with either through a Compose template, or even just sort of directly on the command line, issuing effectively service enable commands to turn on things like etcd, or to turn on a Nagios monitoring agent, or to make this a node within a cluster of, say, Kubernetes. All of those type of things become really easy because the components can be packaged as Docker containers. They can be put up in your private registry or out in Docker Hub, and you can just pull them down, spawn them up, and add capabilities very quickly to the system and upgrade them just as easily. So this is what we've built with RancherOS, and I want to turn it over to Darren now and let him sort of talk about show you how this all works and give you a feel for using it. So Darren, I'm going to make you the presenter. Let me know when you've got the ball and you're sharing. I can tell you when we can see your OS or your website. Okay, I can see your desktop. You're on.
Okay. Sorry, I'm actually sharing this through a Mac, which is then doing a remote desktop to a Linux machine because I don't want a Mac. So hopefully it's not like too laggy or anything. But so I'm going to go through and just demo all the various aspects of RancherOS. And live demos are always fun, so hopefully this all works. So first thing is, if you want to go and get RancherOS, just go to our GitHub page. So we have the org RancherIO. and then OS. You can also just find that from rancher.com. We'll have links there. But down here, we have basically the different ways you can install this is we have an ISO. So if you just want to download the ISO and boot it from a virtual machine, or even you can even write the ISO to a USB drive and boot it off of bare metal or burn it to a disk or whatever. So we have the ISO. We have Amazon, or we have AMIs in most of the regions right now. We just have TV, HBM will come soon, and we're working on adding quite a few more clouds right now. But initially, we're just supporting Amazon. And then finally, the last way to get RancherOS up and running is actually the Vagrant project. So if we click on there, this is the kind of the most popular way to get it up and running. It's the easiest way. You just first need to install Vagrant, then clone this Git URL here, and then do your standard Vagrant up workflow. So we'll go with the Vagrant approach right now. And so I've already cloned this here. You can see. So I've already cloned the RancherOS Vagrant. So we just type the Vagrant up. I have modified this locally so that it will pop open the GUI, just so you can kind of see what the OS looks like as it's booting. Just enter that. Okay, so as this is coming up, you'll see it'll say like running. So you can see running UDEV, some of the volume things, cloud and network. These are the various system containers that we're running to provide the basically the operating environment. So let me just Vagrant SSH. Okay, so once I'm in, let me just kind of orient you and kind of the environment here. So if I run Docker PS, you can see I have no containers. So as we were saying before, we separate these system containers from user containers. So Docker PS goes to the regular user containers, and basically, so there's nothing running. Now, if I run system Docker PS, now system Docker is just like from a command line perspective, it's just the same as Docker. We just named it a different file name, so it's obvious what it is. But if I do system Docker PS, I can say, okay, I have these other containers running. These are all system services. So at the top there, you can see the console. So the console here is actually running in a container. So your login shell or your SSH is in a container. I have another one here for user Docker, and I have another one for syslog, and then we're running NTP. And if I do a -A, you'll see there's actually a lot more other containers that ran for other reasons, things like cloud init. This was something I was doing a little earlier with upgrading and everything. Okay, so once you get into the system, Docker PS, now you have a Docker host, and you can just start doing anything you know how to do with Docker. But some of the things that are specific to RancherOS was first system Docker, but then there's also this command here called Rancher Control, and this is kind of like the main CLI to do various tasks on RancherOS. So first is the config. We can change some of the configuration. RancherOS is designed that we have basically one configuration file that defines the whole OS. So it should be very easy to kind of define your kind of have a template of the node of what this thing should look like, and then you can just apply that template somewhere else, and that node becomes the same. Second thing we have here is add-ons. These will actually be renamed to service very shortly in the next release. But this is how we configure some of the additional system services, and I'll get to that a little later. Then we have OS. So this is the one I want to talk about right now. Is if you run the Rancher Control OS, this is how you end up doing upgrades and downgrades, rollback, etc. So if I run Rancher Control OS list, I can see these are the various versions that are out there right now. Now these are actually, as you can see this format here, this is actually a Docker image. So we use Docker Hub to distribute the OS itself. So if I run Rancher Control-V, you can see, okay, I'm actually running version 0.20. So I'm running 020. So if I do list, I can say, okay, well 021, that one's actually available. So if I just say Rancher Control Upgrade, it will upgrade to the latest one that's available. Now, to make the demo faster, I pre-staged the templates, but normally what you would see at this point is it would download that template. So it would just do a regular Docker pull, but that's, since I already pulled it, you won't see that. So basically, we kind of put echo on the script here, so you can kind of see the guts of what's going on. But at the end of the day, pretty much what this is doing is just copying in a new initRD and kernel, and then updating the grub configuration, and then just say, okay, do you want to reboot? So now this should go and reboot. Let me pop over here. You can just see on the console here that it's coming up. Okay, so Vagrant SSH. Now, if everything worked, when I run this, I do Control-V. Yeah, so now we're V021. So now if I run OS list, again, if I wanted to, I could say upgrade-I for image, and then the specific version, and that would go back to the old version. So, basically, like with Docker, if you have various versions of your container, you're going to have various, just versions of an image, and so what image you run from is the one that that's the version of your application. And so with the OS, it's kind of the same thing. You can pre-stage all these images, and you just select which one is the active one. So we can actually have like n number of versions staged, and you can pick any arbitrary one.
Hey, Darren, just to cut you off, there was a question that came in just now from Roman Stillman. He asked, what does upgrading mean here? Does the kernel change, or are these just system containers that are changing?
Right. Good question. So basically what's happening is I was saying, it's putting in a new kernel and an initRD. So obviously the kernel is getting updated. And the initRD, basically what the initRD has in it is the Docker version, like our RancherOS, essentially like glue code, and then the core system service containers. So when I do a system Docker PS here, these containers are all getting updated too. But if we were to add more system services, and I'll show that in just a second, those don't get updated during the upgrade. So the OS itself is just this tiny, like 20 megabytes or around there. And so when we do the update, it's just that small portion. So if you're pulling in, etcd, or you had Kubernetes installed, and you do an OS upgrade, it's really not touching the rest of those system services. You can manage those all independently.
Great, thank you.
Okay. Okay, so let me go on now to, let me show you, I'm going to bring down this Vagrant environment here. Log out, Vagrant halt. And I'm going to switch over to, because the Vagrant environment I was showing, that was the latest release that we've cut, which is 021. But I want to show you some of the things that we're working on. This should be released within the next week. Most of this is done. We're testing the things. But let me bring this up. I'm going to run this in KVM, so it's kind of like more of a development setup. But I want to show what we're doing with our system services. And we're pretty excited about this feature.
Hey, Darren, while you're answering that, there's a couple more questions that have popped in. So the first question came from Yaz Atlas. He asked, have you been working on implementing ksplice to update the kernel without a reboot? So do you want to take that one?
No, well, so we haven't yet done anything, but now that that's going into Linux 4.0, then it opens up a huge realm of possibilities, because one of the things is, like, when we looked at the core system containers, they only, like, that 20 megabytes has some of the core system containers. We could theoretically update those independently, but it kind of didn't make a lot of sense, because, like, it's such a small footprint. Like, we can download it with the kernel. And if we do a kernel or a Docker upgrade, we're going to have to do a reboot anyways. But as soon as you look at something like with not necessarily ksplice, but what's going into Linux 4.0, which is, I can't remember the exact name for it, then you can do live upgrades of the kernel, And then it would make sense that we can actually start doing increment, like some of the core system services, we just update those by themselves. So it could be possible, like, if we adopt what's in Linux 4.0, it could be possible to fully manage completely the upgrade of everything dynamically and not require a reboot, which is really quite amazing. Because there's some things, even like there's some core things like you wouldn't normally upgrade without a reboot, but it gets pretty close to 0 reboots needed. So I mean, I think it's pretty exciting, and I'm looking forward to actually working on something in that realm. But it is kind of a little bit out there.
Great. And Yaz, if you have follow-up questions or anything, feel free, anyone, to just keep firing away questions. There's another question, Darren, that came in about that came from Sinoth Grandi. And Sinoth was asking if system containers that are not part of initRD, he was basically asking whether if you have system containers that are not part of initRD, then they do not get upgraded when you do an upgrade. Is that correct?
Yeah, they do not get upgraded. So the upgrade of those would be managed independently because you're basically supplying what version should be running. So when I show you some of the compose support, you would basically be pulling in a new compose template, which would have a definition of a new version to do the upgrade.
Excellent.
Yeah.
Just on that, guys, as questions come in, I'll try to, I know some people have asked questions earlier about some of the stuff I was talking about. Darren's going to show some of those things like, how to swap out services and stuff. So I'll try to bring those questions up as they make sense. So thanks. Keep asking, and we'll keep answering.
All right.
One more question.
Okay.
How does it upgrade? This just came in. That I think it's right on the same topic about upgrades. How does an upgrade affect the user space containers? Was the question.
Yeah, so the same thing. That kind of falls in the same bucket as like the non-initRD system services. So they're not impacted at all. The only thing would be is if a new Docker version came in, like the new version of the OS had a new version of Docker, then those containers would now be running under a new version of Docker. But we won't touch those. They should come right back up.
Okay. Thanks. That question was from Sagayaraj. Hope I said that correctly. And any other questions on upgrade before we move on? All right, then let's get rolling.
Okay, so what I've done here, I've SSH'd into, I'm running this is like a development version of RancherOS, which has the kind of the system services and compose support. First, I wanted to demo. Okay, so before when we talked about, so there's this command add-on. So you can say add-on list. Again, this will probably very shortly be renamed to service. I kind of wanted to get that done before the demo, but unfortunately I didn't. So when you say list, this is listing kind of what's of the available services or whatever that Rancher knows about at this time. And so if I look right now, I'm actually running a BusyBox console. So you can see, like, maybe from this top output or whatever, it's not the the normal, that doesn't look like a regular normal top output or let's see, like, oops, like, there you go, list-h doesn't even do the right thing. So this is a BusyBox shell, and obviously the reason why we picked BusyBox is because it's tiny, and it's a very small footprint. But honestly, that's not the best user experience. Most people don't like to work in a BusyBox environment. So one of the examples we kind of talked a little bit about this before is that we can swap out the console. So what I can do is say Rancher control add-on enable Ubuntu console, and then if I go and I list. So you can see now it's enabled. In the future, we'll probably do this all dynamically and restart the containers, but right now it does require a reboot, so we'll just quickly reboot here. So, let's see. Okay, that's about up. Okay. Okay, so now that we're in here, if I run top. Basically you can see this is a better looking top. This is, so I'm in an Ubuntu. And, oh, I guess ls-h is not what I thought it was. Anyway, so this is actually an Ubuntu console. So if I run sudo system docker ps, you can see the console container here is actually coming from Ubuntu console. So I just swapped out the console. So you could imagine, you might have a Fedora one or an Arch Linux one if that's the environment you really like. Because what the console really provides is just somewhere to log in and run some utilities, but it's really independent of the rest of the system.
Darren, that actually lines up with a question that just came in from
Sure.
Roman. He was asking, what does the file system look like inside of the console? If I write to files, does that show up outside of the console? Is there a specific disk location mounted in? That kind of question. So.
Right, that's an excellent question, because one of the trickiest things so far about RancherOS is a lot of times people ask, what's your host OS, or what does the host look like? And honestly, there's not really a host OS. Like there's very little, if anything, in like the host context. So that can be a little tricky because you have, let's say, user Docker running in this container, and then you have like your login in this container. How do they share files and things like that? So some of the things that we've done to make it just a little bit easier, and I'll see if this gives us much of a useful output. System Docker inspect console is, you can see we actually bind mount in quite a few volumes here, and some of the volumes are, the key ones are like home and OPT. So what we do is we try to share some folders across the system containers to make the file system look consistent. Since each one does have its own root, but certain directories will bind in. So everyone has the same home, everyone has the same OPT. And then there's some other things we're adding, like, so we have certificates that we're sharing, and we'll probably end up sharing like the user database, like password, group, and shadow. So this is like, if you're at all familiar with kind of the guts or internals of how boot to Docker does their volume sharing between the host and like if you run a Docker command and you can share your user directory from your Mac. We do a very similar thing of like we mount in the home directory. So you can do something and say like Docker run something like that where it's you're bind mounting in the current directory, and this will just kind of seamlessly work because we've shared that home directory. So again, I realize that probably was a kind of a confusing explanation, but the short of it is home and OPT are basically shared across all containers. So if you want to bind mount things or whatever, you can trust that those directories are there.
Thanks. Roman, I hope that answered your question. If you want to ask a follow-up, feel free. There was another question that came in from Yaz, and he asked about a little bit about RancherOS and networking. So let me see if I can read this right. Provisioning RancherOS, he's guessing it configures the network via DHCP. So in a non-vagrant setup, a reboot would then cause potentially an IP change to RancherOS. Is there a way to set static IPs?
Yes, there is. And so basically what we've had to do is we've implemented like our own kind of networking configuration. Basically because there's not like particularly a great standard out there of how to define networking. And so in the documentation here for networking, basically you can define what interfaces have DHCP, which interfaces have static IPs. And I mean that's most of like the basic configuration. And then there's some hooks that we have in there that you can like call a Docker container to do additional configuration if you want to do more advanced setup like bonding and stuff like that. But the basic setup is looks like that. I might be able to, if I turn this off, but we can try to go back to our Vagrant and see how that one is actually set up. Because to be perfectly honest, I'm not like an expert on Vagrant, and I know we do some tricks networking because in Vagrant, you can, I think, specify multiple NICs and say what the IP is, and we do some little tricks, or I think we have a custom plugin or something like that that will actually set up those IPs and everything for you. So let's see. because yeah, I think it's right there. It says controlling and enabling network interfaces. So let's try vagrant SSH real quick. Sudo rancher control config export. This is where you can just dump out the whole config of the OS. And let's see. Right, so you can see the networking here. We set ETH0 to DHCP, and then ETH1 we set to this IP, and that was somehow transferred in from Vagrant. If anybody is a Vagrant expert, you can look at basically what this Ruby plugin is. So hopefully that answers your question.
Yeah, thanks. And yeah, I think there's a follow-up that you guys asked just about IPv6
Sure.
support. Is there any either current or planned support for IPv6?
Yeah, so we plan to support it. Basically, in order to get into like we want to run in DigitalOcean, and so DigitalOcean has IPv6 support, and so we'll be adding that. So I mean, our support of IPv6 is basically through the network configuration, you can apply an IPv6 IP and whatever information you need. But beyond that, it's been just Docker, and they recently added IPv6, and so for sure we're going to support it, and I think that should be relatively soon. It's not like a one day. It's going to be very soon.
Thanks. One other question on networking before we jump on from there. Thomas Tree asked, so does support exist for more advanced networking like Open vSwitch, GRE tunnels to bridge Docker networks across RancherOS hosts?
Right. So what we wanted to do was, because we kind of saw that we needed to actually program a network configuration utility. So that's written in pure Go. But it's very simple. It's a very simple configuration. So now if you get into OVS and those other things, you're now just kind of going into more like you can provide a container that would then have the scripts and everything to set that up. So specifically like OVS, one of the guys from Socketplane had OVS running on RancherOS. When we first announced it, because OVS actually you can package in, or all the user space and everything you can package in a container quite well. So we don't, by default with our configuration, support some of these advanced setups, but we feel there's all the proper hooks so that you can do that all yourself. And so what we've already seen is, Rancher, our other higher level orchestration stack uses IPsec, tunneling across hosts. That's working. We've seen OVS working, VXLAN. Yeah, so I think hopefully most everything you can accomplish.
And as we get further into the Rancher, we'll show a little bit of Rancher. We'll actually show how the networking works in Rancher. Okay, a couple more questions real fast before we jump forward. There was a couple more on the console and the upgrade. So just going back, this is Richard asked, when you upgrade from one version of RancherOS to another, do you foresee backwards incompatible upgrades? For example, if I get this up on a box, we'll be able to internally upgrade all the way back to 1.0, 2.0, or will there need to be a fresh bare metal install along the way? So how dynamic is the upgrade process, I think is the question.
Right. So basically that's going to be, it pretty much is like how the support for whether or not let's say I'm on version 34 and I want to roll back to version 20, is that going to work? That largely is dependent on Docker, because at the end of the day all we're really doing is launching containers, and the state that we're persisting on disk is really the container state. So Docker in general, I don't think they support going back many versions. I know they do a couple versions. So it's largely going to be up to what Docker is going to support. So I wouldn't say that you could probably forever roll back to anything, but within the last couple versions would probably still work fine. Like the main use case that we're looking for here is you do an update, something doesn't go right, you just roll back, and so that should always work. So it's important for us to maintain that level of compatibility. I know it's important for Docker too.
Okay, great.
Okay. Should I keep going on? Or?
Yeah, I think we better keep
Okay.
moving. Guys, if there's questions that I haven't been able to answer, we can definitely go back and answer a couple more follow-ups in a bit. Let's let Darren keep moving a little bit here.
Okay, so I wanted to show you some things here. So we have this file RancherYAML. So like when I ran that like enable to enable the Ubuntu console, you can see really all it's doing under the hood is just editing this file. And so it says enabled add-ons. It added the Ubuntu console. And so this is how we can add in more services. Now we talked about, we kind of mentioned before, well, we can define services using a compose syntax. And so what I've done here is I have etcd. Actually, there's one line I don't even need in here. Just don't want to confuse you there. Okay, so we look at this. This is actually, this is just using a normal compose syntax. So it defines etcd. Now links, we've kind of overloaded this a little bit because when you define a service, you want to know what are its dependencies. Like, can I start this one up before another one? And so we largely use links to determine the startup order. So we have etcd. We say, okay, etcd needs networking. Restart always. So this is kind of your restart policy. The networking is host. Right now for system containers, we only support host networking. We'll probably support bridged also, but right now we've kept it simple with just host. So you specify the image, and then this is just basically just a regular etcd command. So now if I take this file, so I can now edit my Rancher config here and just say, okay, I also want to load in this file. Now this can be an HTTP URL also. It doesn't have to just be local disk, but for the sake of this demo, we're just going to do it local disk. So again, we will make this all dynamic in the future, but right now we're going to do a reboot. So now let's just give it a second. So now when this system comes back up, it's going to read that compose template, and it should launch etcd. So let's see, we should see it actually in I don't know why that took so long. That was scary. Okay, so you can actually see 11 here. etcd started. So if I log back in, sudo system docker ps, so you can see, okay, we've actually we've logged in etcd. We started etcd. So you can imagine, because like if you want to launch, let's say like something like Kubernetes, you need etcd running, you need flannel, you need a Kubernetes master, Kubernetes minion. So you can imagine you could create a series of these composed templates of, okay, here's the template for flannel and etcd. Here's the template for what a minion would look like, and then you can just load those in on your server. And now anything that comes in let me go back to the documentation here. So basically anything that you can configure in that RancherYAML that I was showing you, you can also put that in the cloud config. So let me pull up the README here. There's a little bit of documentation. Oops. So basically, if you have a cloud config, if you're familiar with Cloud Init, you can set some of the standard things here, but you can also put any RancherYAML specific configuration here. So you would put a line right here, which would be enabled services, and then you put the reference to the YAML file, most likely an HTTP URL to that YAML file. So now from the cloud config, you're now saying, okay, here's all of the services that need to be ran on this host. And I can even show you here internally, if I do Rancher control config export full. So let me go down. So this is, as I was saying before, this is the full configuration of the OS. So right here is system containers. This is basically the composed template of the entire OS. This actually, we use this, we essentially have defined one template which encapsulates all the system services. So these are some, some volumes. This is Cloud Init itself. This is the kind of the stage 1 Cloud Init. Some other random ones. The console here. Networking. So you can see the entire, everything we've actually already switched over to this composed syntax. And so we really, sorry.
No, go ahead. Finish up your point.
Okay. So I was going to say we really see, going forward that you could really describe, pretty complex configurations of what your node and what needs to be installed there, all through this composed syntax, and then just loading it into your cloud config. And I mean, so that mostly wraps up the kind of the system services, how that works.
One of the questions that came in while you were talking, and I think it's relevant because you were talking about using system services to create a Kubernetes cluster. But Brandon Rabbit asked, are there plans to make RancherOS clusterable so containers can be run on and scheduled independent of a specific host? You just want to talk about clustering and Swarm and Kubernetes and
sure.
Sort of Rancher and how these things work.
So the thing is so RancherOS at its lowest layer, we want it to be just a singular unit, very simple to deploy. But when you think, well, what does it take to cluster something? What's a CoreOS cluster or whatever? It's running these clustering software on top of it. And so we want to support these things and make them extremely easy to get up and running. So that's one of the reasons why I showed SCD here is, you should be able to get SCD up and running really easily on RancherOS. So you can essentially create an SCD cluster with RancherOS nodes. So SCD is one of those. Docker Swarm will of course support natively, and so then you'll be able to create a Docker Swarm. Additionally, Kubernetes, we actually already have Kubernetes running on RancherOS. So it's kind of RancherOS by itself. We just want to keep it a singular unit, but kind of all the software that's out there to create clusters of machines, we want to support. We've been spending a lot of time trying to get basically every Docker project running on RancherOS.
Thanks, Darren. Just because we're kind of nearing the top of the hour, and I just want to talk about time for just a second because we're not going anywhere. Darren and I are going to be around. We're going to be answering questions, showing stuff, talking until we've answered everybody's questions. So don't worry about time from that perspective. If you have to run to meetings and other things, we are going to be trying to record everything, and we'll make it all available. You're welcome to come back later and watch what we've covered. So I'll just that's one note on time. One more question that came in, Darren, from Andreas Steinius. He was asking, since the OS is composed of containers, is it also possible to run multiple Rancher systems on a single physical host? Yeah, when we first started developing RancherOS, we were running RancherOS in a container, which was just so many levels of inception. But it's not so feasible to actually run RancherOS multiple instances of it because the system containers, some of them have a higher level access to the host that you can't have the two of them running at once. So an example of that would be UDEV. So we run UDEV to do the cold plugging and hot plugging of devices, and so you can't run two UDEV containers. So it wouldn't actually be possible. Those don't isolate very well. So one of the things that makes system services, system containers, a little different from your regular user application containers is you want your user application containers to be well contained, isolated from each other. But with the system services, you want to give them access to certain things. And certain things in the kernel are not really namespace aware. You can't have multiple ones, and so they end up, basically it won't really be possible to run multiple versions of RancherOS next to each other, unless you use virtualization, or we did a specific build of RancherOS that disabled certain services from running in parallel. A couple more questions on this. One came from Trevor Roberts Jr. He said, "What is the RancherOS equivalent to Fleet for managing services across the cluster? For example, what makes sure that the Kubernetes components stay up?"
Yeah. So there's the basic staying up is handled by Docker itself, which is you can put restart policies, so Docker will make sure it keeps running. But that doesn't. What happens if you get a node failure? Can you schedule it somewhere else? So the Fleet equivalent is essentially Swarm, or we're doing very similar things in Rancher itself, which we'll talk about a little bit down the line. So I mean, basically, so far we haven't needed to. Haven't felt the need to actually create something specifically that's a replacement for Fleet, because we think Swarm is really basically pretty much on par with that. So, yeah.
And that kind of is a great point. One of the things with Rancher, both Rancher and RancherOS, I mean, we've really sort of optimized this around the Docker ecosystem, and you'll see. We're using Docker Compose to define the system. We're using, we're focusing on native support for things like Docker Machine and Docker Swarm. So we'll talk a little bit more about those in a second. Darren, did you want to add anything more?
No, that was good. Yeah.
Okay. And guys, just one thing to remember: if you ever run into these questions, if you're playing with RancherOS later and we're not in a meetup and we can't answer your questions, feel free to shoot them over to GitHub. We just track an issue, raise an issue, ask a question. We try to be really good about responding, so don't hesitate if you've ever got issues. A couple more questions.
And I mean,
go ahead,
Darren. Say, if you have a question, don't hesitate to put in an issue that is just a question. That's perfectly fine.
Yeah, and we're on Freenode, and we've had a Google group, and there's other ways to get a hold of us.
Yeah.
That's always good. The best was really, GitHub is one of the best. It gets responded to really quickly. A question from Richard Bucker. Is it possible to run X11 etc on top of RancherOS?
Yeah, it actually is. And so, that's something we've been fooling around with, because it's kind of like, can we actually run a full desktop on RancherOS? And I haven't say I've completely succeeded in creating a full environment, but X11 will work. Basically, it's just you can Google around on how to get X11 to work in Docker, and it's just a matter of sharing the socket and the the environment variable for, I think, X authority or something like that. But yeah, it will work, and so I think you can actually create one big Ubuntu desktop container, and it will work. But actually, this is something I really like to explore more of, the idea of packaging up a lot of GUI or client-side applications into little containers, so you can have just a fully containerized desktop. But so it should work. It's a fun thing we've been fooling around with, but I'll be honest, desktop's not really our focus.
Another question, this is kind of a follow-up question to the earlier discussion about sort of swapping out the consoles. Signoff was asking if he uses a Fedora console, would the paths for system utilities also change?
Yeah, so one of the things when we create, so if I look back and I do an inspect on the console. Oops. Oh, sorry, wrong command. System Docker. Okay. So the commands that we care about, sorry, I think they're up here. We actually bind mount in the commands we care about, because some of them are important, like reboot and power off and halt. We have to do the power functions because we've taken over init. So for the core commands, those stay consistent across containers, but then consistent across consoles. But then beyond that, if it varies in distros, then it will, the locations of things will vary. So we don't try to give you a consistent experience across various consoles, because I mean, that's kind of the point, is that you want a different experience. So if it's slightly different, then it's slightly different. We're trying to make this even easier, just to get in a little bit into the guts. Like when we start up the console, we run this one shell script, which does some things around like SSH and setting up home directories and passwords and stuff. Is we're trying to minimize this script, actually write it in Go and do do less, so that if you wanted to support a new console, you would just like bind mount in one binary, and it kind of handles the generic stuff that needs to get set up, which is like SSH keys. Yeah. So right now we have basically
just FYI, you're having a little bit of audio distortion. So some of your,
really?
Not sure why, but you kind of broke up there a little bit during that answer. So hopefully it will not continue. It must be that British network. Okay, so two more questions that I want to try and jump to before we jump forward. One is from Tariq Iqbal. He asked, is there a roadmap for RancherOS that's published or that we can find?
No, it's not actually properly published. That's kind of a shame. We should put out a roadmap there. So I'll tell you that the main thing we're focusing on next, like the next release, which would be like our 0.3, which should come out within the next week, is these system services that we're showing. So basically the compose template, make sure that's all flushed out and everything works and everything, and then better bare metal support. Right now, if you download like 0.2.1, we just didn't compile in a lot of the drivers that you need for bare metal. So the 0.3.0 has a newer kernel with a lot more options turned on. It seems to work a lot better on bare metal. So that's what the kind of the next release. I think the 0.4, like the next milestone after that, is really about supporting clouds and hypervisors. So right now, kind of the only things that are officially supported is like the Vagrant, the ISO, and Amazon. But we're trying to get all the major clouds, so GCE, Azure, DigitalOcean, some bare metal hosting companies, VMware, like Fusion on your desktop, and then the biggest one is machine. We really want to get Docker machine provisioning in RancherOS. So we already have done some work on that. So that's kind of the short-term roadmap. Honestly, we don't expect the scope of RancherOS to continue to grow and grow, because we really do want to keep it as this kind of singular, flexible unit. And so anything beyond kind of what I've talked about is really kind of based on user demand. Let's see where this goes and what people, if there's certain gaps that come up. So
one of the things, Darren, that we've talked, we've had a number of people talk about kernel, swapping kernels as well. You may want to touch on that.
Yeah, and so that kind of goes in with the when I said like supporting different clouds and stuff. That's it's not just like supporting different clouds. It's kind of like just making this thing so it's very easy to configure and deploy in different environments. Because like bare metal, people might have very odd drivers and stuff, and we might not want to include those by default or whatever. So we want to be able to make it so that we'll probably have a supported set of kernels or kernel. But if you want to pull in your own kernel, if it's a highly optimized one or a GRSec or something like that, or you want to use a Red Hat kernel, we will make that very easy. So it's a really interesting side effect of RancherOS is that what we really care most about is Docker, and then we run all these containers in Docker, and so it's like we begin to care less and less about a lot of the specifics of the kernel. And so since we have this like good layer of container portability that works against the Linux ABI, which is really stable, we can swap out kernels much easier. So that should be coming in like the same 0.4 release.
Great. A couple more questions that have come up while you've been talking. And the first one is, how do you handle kernel modules? Brian Olson asked, can system containers add modules, and what about when the kernel gets updated? How does that work?
Right. Yeah, that one's a super fun one. So basically, I mean, with the kernel and the init.rd, we ship the kernel modules, and so so they stay in sync because those kind of get shipped together with the OS. Containers, if you give them the right privilege, can load modules, and that's how we can run like udev in a container. It loads modules. Things like IP tables will load modules on demand. So basically, like loading packaged modules is very easily doable. We're already doing that today. The more interesting thing is, say, something like ZFS, and this is something we're actually actively working on. Is how does somebody deliver custom kernel modules? And so the approach of what we're thinking is I mean, it's really no different than how do you do it in Debian or Red Hat. So if you're going with a Red Hat approach, it's basically I pre-compiled these kernels for these certain versions. Like Red Hat does a good job with ABI compatibility. We're not necessarily going to do that, but if you've already pre-compiled the kernel, then on startup you can pick the right one and load it in. That takes a lot of effort, but that's definitely one approach. The other, which I think is much more fun, or interesting, is like the idea of DKMS. And so basically you can have a container which runs DKMS in it. So this is what we've already tried with ZFS. Is we package the kernel headers, they get bind mounted in. So, you just basically run DKMS, it builds the latest one and then installs it. So we're playing with various approaches. Like a third approach is we can actually produce a kind of like an kernel SDK Docker image for each version. So you can just do a Docker from and then compile your kernels. So that one is like, yeah, it's doable. There's different options, and we're trying to figure out really what's the best one. And I think that will kind of get flushed out as we do a ZFS, because we've had a couple of different people ask for ZFS support.
A couple more questions, Darren. One came from Roman. He asked again, has the log rotation stuff been addressed? If I deploy RancherOS box today, when will the system containers fill up the logs?
Very soon. Yeah, so the current version, like if you deploy 0.2.1, yeah, you will have issues with log rotate, but like we're not, kind of naive to those issues. And so what we've done is Docker 1.6 has a logging framework in it. And so we, like at Rancher Labs, we did the work for adding syslog support to 1.6, and so that will be in Docker 1.6. And so as soon as 1.6 is out, RancherOS will have the corresponding release. So that addresses the system containers. All of them by default will actually go to syslog, and we'll be using our syslog and log rotate to be handling those. Now, for containers that aren't using syslog, what we've also put in a PR for is the ability to do log rotate on Docker. And I don't think it's going to make it into 1.6. But that PR is out there. It will get, there's no reason to believe it won't get accepted, but it might land in 1.7. But one of the things that we are doing right now in RancherOS, because this is alpha and we're moving very quickly, and we're kind of moving, it's kind of like we're on alpha of Docker also, is that if we know a PR is going to be merged in, we will actually package it into RancherOS, and so we kind of carry some patches, and so the log rotate functionality will actually be pulled into RancherOS. If it doesn't get merged into 1.6, we'll just carry the patch until it does get merged. So log rotate should be addressed. So in the current version 0.2.1, it's not addressed. I don't know if we'll get it all sorted out in 0.3.0, but might be like 0.3.1. We basically have all the bits. We just need to piece it all together, make sure. So that should get addressed.
Thanks. Good question, Roman. A couple more questions. One is from Sinath. He asked, he said, using initRD normally slows down the boot time. So why did we choose to use that?
Yeah, that's a good question. It does kind of slow it down. So one of the things is we're not shooting for super fast boot times. I mean, super fast boot times are fun, but if it takes a couple more seconds, we didn't see that as a big problem. I'm open to hear if you have issues with that, or in your environment you really need fast boot times, but they still do generally boot fast. But so the initRD, the reason why we just went with the kernel and an initRD was because the delivery mechanism and everything was so simple. Because basically, like if you're PXE booting a server, you can easily get that from a TFTP server or however you deliver it, through iPXE or something. Or if you're doing like a grub configuration, you just point to which one you want. So it just made it very nicely packaged, and since it was only like 20 megabytes, it's not huge, but you will see, like if you boot up RancherOS, you will see it hangs for a little bit at the very beginning while it's loading that initRD. So it is a good point that it does slow it down a little bit.
Great. One other question. Charlie Draga, maybe, asked, does RancherOS load a user data metadata from ISO on boot? He's only tested it with rancher-install/dev/blah blah blah -c rancher yaml. You may want to read this one, but hopefully it makes any sense.
Right. So I'm assuming you mean the like OpenStack config drive support, and yes, we do. And you can see in like CloudInit, basically we look for label config2, and we also look for a special 9p FS. And so for development, we use this extensively. When we launch KVM images, we use the OpenStack config drive format to load in the cloud config. So that should work. So what we've done is the data sources for CloudInit, we're leveraging all this, like all the work that CoreOS did. So we have all the same data sources. Not all of them are turned on necessarily, but if you find one that CoreOS supports that we don't, then we can very easily turn it on because we're leveraging that same code base that they've developed.
Okay, a couple of them questions. Let me see if I can get through these. So one is, can you, Sinath asked, can you please elaborate more on delivery mechanism? How does it become easier with this? I don't know if that's
because of the kernel and the initRD? Because the kernel and the initRD are just two files, and bootloaders know how to load files. Like if my delivery mechanism, like if my OS was something else, like it's actually an installed thing on disk, they're gonna have to worry about installing that to disk. So, for example, like the CoreOS has a predetermined partitioning scheme. Like they have, they use GPT, and they have certain GPT GUIDs or labels like user A, user B, and so to actually install CoreOS, you need to have like kind of that partition layout. So it's just one extra step, and so we just thought it was very simple to be able to kind of PXE boot this thing, because we have this kind of idea that this is a very small, lightweight. If you're familiar with like VMware, it's kind of on par with like ESXi. It's just a tiny little thing. You could boot it from an SD card or something. And so we just wanted to make that super easy. Now, having said all this, there's nothing that actually precludes you from taking that initRD and putting it onto disk and booting off the disk without the initRD. It just requires like some more manual setup. There's really nothing super kind of fancy here.
So a good question from Brandon, another good question from Brandon. He was asking, let me see if I can read this right, do system containers get automatically restarted if they crash for some reason? And if so, if someone misconfigures a system container, could they cause an infinite restart loop for that container service in the system Docker and ultimately crash the system Docker process?
Yeah, good question. So the restart is based off of Docker restart policies. So if you launch a container and you don't set a restart policy, then basically if it dies, it dies. You can, if you want it to be auto restarted, you can put, there's restart policies of like on failure or always. And basically the behavior right now in Docker is if you say restart always, it does an exponential backoff, which means like it'll run, and if it fails, then it waits a second, then it waits 2 seconds, then 4 seconds, 8 seconds, 16 seconds. So it, it tries to very quickly restart it, but if it's not working, it just keeps slowing down and slowing down. So that works kind of well. If you have a container that continually fails for a long time, you'll suddenly see that, like, because they don't cap the exponential backoff, suddenly it'll be like not trying for another 16 hours, then not trying for 32 hours, which is not great. So what we've done there is we have, I'm not quite sure if we've put in the PR yet. We have the code. If we haven't put it in the PR, we'll put it in shortly. But basically, we've added. There's a proposal I know is already out. Like basically, there's a proposal, and then we have the corresponding code for it, which is we've made it so restart policies can be a fixed interval. So you can just say we'll restart it every 5 seconds. So it's just always at that same fixed interval if it fails or for any reason. But we've also added a syntax in there to make it so we can add other arbitrary arguments to restart policies. So I can imagine, like, one of the things that we wanted this restart every is because it's kind of like a poor man's cron. We specifically needed this for log rotate. So we wanted to run log rotate like every hour. So we can just create a container that runs log rotate and then dies, and then Docker will restart it in an hour. So with you can imagine, like, maybe in the future with the configurable or like the optional restart arguments that you could put in like a cron syntax or something like that. So we think there's kind of sufficient framework and power in Docker, that we can add the things that we need to address these type of situations. Okay.
All right, so I think we've covered a lot of questions, and we've gone through a number of different things here on RancherOS. So I'm going to try and move us forward because we wanted to talk a little bit about orchestrating RancherOS and what Rancher can do around it. So I'm going to take back control here, Darren, and we're now at an hour and 20 minutes into this, so certainly understand if people need to run, but hopefully you can stick around and enjoy this. Otherwise, as I said, we'll be making all this available. Okay, Darren, is my screen up? Can you see my
yes.
PowerPoint?
Yeah, I can
Great.
see your screen.
All right, thanks.
Okay.
And feel free to stop me if any questions come flying in while I'm talking.
Sure.
So first up, just again, thanks a lot for everyone joining this. And if you'd like to get your hands on some, as I promised, some nice Rancher swag, we will be handing out and emailing out T-shirts to the first 10 people who tweet that they what they thought of today's meetup. So please do let people know if you like what we're doing. That would be awesome. So we really appreciate it. So now I'm going to talk a little bit about Rancher and just sort of explain how what Rancher is and how it works with RancherOS, and we'll jump into that, and then Darren will get into another quick demo. Basically Rancher is an orchestration platform designed from the ground up to manage Docker and to manage Docker in a way that that really focuses on orchestrating the infrastructure and orchestrating the Docker environments, but doing it underneath the Docker frameworks that Docker is developing themselves, and that means looking at solving some of the trickier problems with moving Docker into your CI/CD process or into production, such as managing networking and managing storage and managing logging and managing users and orchestrating deployments and monitoring and things like that. So we really wanted to solve the infrastructure and ops and orchestration challenges that we saw when you started moving Docker to scale, but we didn't want to do it by building another clustering system and building something on top of Docker. We wanted to sort of look at it from a different perspective, sort of coming from the ground up. And we thought that if we could do that, what would be really interesting is that Rancher would be able to effectively build almost something like an overlay cloud, an infrastructure stack that would be as portable as Docker is. A set of services that you could run, on really any Linux infrastructure. So Rancher and RancherOS are not tightly coupled. They're totally independent of one another. You can use Rancher on any Linux distribution. Over time we'll certainly take advantage of some of the cool stuff RancherOS does with system services and things like that to add more capabilities and try and make add value between these two systems. But fundamentally, they really serve different purposes and don't require one another. So Rancher sits on top of really any Linux host. It can consume resources from public clouds, from VMware, from bare metal servers. Anywhere that you can run Docker, Rancher can manage that host. And Darren's going to show you what it looks like to add hosts and capacity to Rancher. Rancher itself is effectively a control plane. It runs as a container, and it then implements a fully managed set of infrastructure services like networking and storage and load balancing. It manages the resources of this capacity that you're making available to it. It provides user management and project management for your environments, and it implements a lot of capabilities around sort of supporting the Docker application ecosystem. So things like Docker Swarm and Docker Compose, and making those work really well with networking and storage and service discovery. And then it handles some operational functions like monitoring and stuff. So setting up Rancher is really, it's incredibly easy. It's easy. It's just a container. You deploy it on any connected host. You can deploy it as a cluster, and you can scale it to big, as big as you'd like. But once you've connected it, you can connect it to your private Docker repositories. We just added that feature last week. So we'd always supported Docker Hub, and now you can connect it to whatever private repositories you're using, and then you can connect it to a directory service. Today we just support GitHub out of the box, but you can imagine connecting this to Active Directory or LDAP or anything else that you have for user management. And once you've done that, everyone that you give access to will have effectively an environment that they can start to register hosts in, and they can do that in a couple different ways. And certainly hosts can come from just about anywhere. As long as it's a Linux machine, it can be running locally, it can be running in a bare metal cluster, it can be coming from a cloud provider, it can be running on VMware or Xen or KVM. And really, to register machines, you sort of have two options. One is we support Docker machine. So we just recently introduced the first Docker machine support into Rancher, and our initial partner that we're supporting is DigitalOcean, but eventually you'll be able to really use any Docker machine driver for any cloud, and just basically pass through your credentials and select the type of host that you want to add, and you'd be able to do that from either the Rancher API or the UI. Otherwise, you can take any Linux machine that supports Docker and just issue a Docker run command that we provide that allows you to mount, effectively connect that machine and register it with your Rancher environment. Once we have those hosts, we start to monitor them. We look at their capacity, what's deployed on them. We monitor the actual performance of the network and the CPU and RAM and everything for those machines. And then we let you deploy containers. Much like you would deploy VMs in a cloud, you can spawn containers through the API or directly. You can create individual containers. You can create swarms of containers. You can, once you've deployed them, you can monitor them. You can monitor the performance, the utilization of the container. But where Rancher really gets cool is sort of some of the infrastructure services we add around those containers as you spawn them. The first one is we create a private network for each environment, each user or each project. We basically set up a private network using an IPsec-based SDN. Darren talked about it a little bit. We'll show it to you in a minute. But basically, it means that whether your containers are running on the same host or running on different hosts or even running in different clouds, they're going to be able to see each other on this private network. And you can sort of see it down here, this 10.42 network that's running on all the containers. It's obviously different than the public IP address in these machines that are running in Google. And that's that's the idea, is to set up private networks between these containers. And once you've done that, concepts like linking and setting up load balancing, doing service discovery start to really become possible. In fact, one of the things we're going to be releasing next week is load balancing support in Rancher. So we'll be able to effectively offer a container-based HA proxy service that any user can spawn up. You can scale it across any data center or local group of machines. It'll be connected and integrated with service discovery functionality we're working on. So it'll really be part of how you describe applications and handle inbound web traffic predominantly. But it'll be very similar to something like Amazon's ELB or other load balancing services you would expect in a cloud environment, but designed just for containers and to consume containers and distribute workload across these containers, which can be quite ephemeral and change quite a bit. So, so we're working on that. You'll see that in the next in the next week or so. And then the next big piece of infrastructure service that we'll be rolling out is storage. So today we support sort of simple volume management within your Docker containers, but the really the more exciting functionality that we're working on right now and we'll be pushing out over the next month or two is support for a device mapper-based volume management, where we can take incremental crash consistent snapshots of container volumes and back them up to an object store like Amazon S3, so that you can set policies of taking snapshots every few minutes, or you can back up the disk and snapshot it and then move it. So starting to move towards container volumes that are more like cloud EBS-like cloud volumes. Obviously EBS is replicated. This initial version of the storage is not. It's just a single instance that you can back up. But as we progress further, the kinds of things we're looking at is how to mirror volumes and how to start offering at a container and a fully portable level services like storage that are persistent and reliable and can be clustered. So all of this is stuff we're working on or have made available. Hopefully it gives you kind of an idea of what we're doing, but no better way to see this than to try yourself or to take a look at a demo. So Darren, are you set up and ready to demo the Rancher environment?
Yes, I can do that.
Okay, let me transfer this over to you. And you are now the presenter. And just while you're doing that, I'll double check and see if we had any questions while I was talking. It looks like
I can't actually. Yeah, I can't actually see the question, so I wasn't able to let you know.
Okay, yeah, we did get a bunch of questions. So let me just sort of ask a couple questions because I know people have to leave and it's getting late. So the first questions came in. Let's see. What is the Twitter tag? So the Twitter tag is down at the bottom of the at the bottom of the screen. It says #RancherMeetup. So try and put that in there. We can find you, sign up, and send you a T-shirt. Roman, you had a question about the load balancer. So will the load balancer support HTTP and raw TCP, or just some subset of HTTP? Darren, you want to talk about that?
Yeah. So the initial support will be TCP and HTTP, and then shortly thereafter we will add SSL and HTTPS. So basically you can do SSL termination, but the initial cut is TCP and HTTP.
Cool. Another couple questions. One was, are the infrastructure services that we're developing also open source? So the work we're doing on networking and storage and load balancing and the likes. Do you want to, and then if so, can we contribute? This is from Sign Out the End, that question.
Oh, yeah, so the answer is yes. This is all open source. Everything is on our GitHub page. So the kind of the two main entry points, if you're looking at our GitHub page, is we have RancherIO Rancher. So Rancher is the higher level orchestration stack that we're talking about here. Looks like it's okay. And so this is where Rancher itself is a fairly large, complex thing, and so it's actually a collection of a series of other projects that are all scattered throughout RancherIO. So the Rancher is a good entry point. You can put in issues if you want to contribute or or if you're looking to, you're not quite sure where the code is for something, because it might be in a different project or module, you can put it in issue or hit us up on IRC, and we'll let you know where it is, because there's various, I think there's maybe like 10 or 15 different projects that's actually composed Rancher. RancherOS is actually much simpler. Most of RancherOS is in the repository OS, and then there's a second one called OS Base, where we house like the kernel configuration and some other things. But for the most part, it's just RancherOS. So these are both on our website too, just rancher.com. But so RancherIO OS or RancherIO Rancher is where you can find all this.
Another question, is the kernel source code on GitHub?
Yes, and basically, so it's right here, RancherIO Linux. When we release the 0.30 release, it is actually going to be built off of Ubuntu 15.04 kernel. We're going to switch over to that kernel, but as you were saying, the feature, we really want to be able to support, multiple kernels, and people can easily change it, but kind of the one we think we're going to stick with and make our default will be the Ubuntu one.
There's another question. This was from, this actually a bit earlier, but Brian Ayers had asked, what was the ETA on delivering Docker Compose support in Rancher?
Yeah, so what I'll demo in just a second is kind of like a beta of it. I would say it's definitely within the next month. We'll have it done. I hope it's actually much earlier than that. I know the majority of the back end's done. We got to put the UI on it. But honestly, if you're just using the command line, you don't even need the UI. But this is a pretty big feature, because we're not just, we implemented it a little differently in terms of Compose today is 100% client side, and we felt the need to have some server side aspect to it to manage some of these relationships in the longer term life cycle of services. If you look at Kubernetes and seeing their replication controller and kind of the power that you can do with those things, that kind of led us down this path of the really we can see a need for a little bit more server side stuff, and so we're working on that. It's so as I said, definitely within the next month. I really hope within 2 weeks you'll start seeing the command line and back end working.
Awesome. Just I know we're now at an hour and a half going on, so I want to just thank everyone. It looks like we still have about 70+ people on the meetup, so that's fantastic. Some more questions. This one's from Abhishek Sharma. He asked, Rancher itself runs in a container, so what happens if the machine running Rancher dies? What is the fault tolerance built around that?
Right. So I'd say we haven't done a very good job documenting this. So the architecture of Rancher internally is actually it's quite scalable and complex and all that. So we have a very good story on actually how to scale this thing. I can show you. This is some older documentation we have. But basically, internally, the way this all works is we have a database, a lock manager, an event bus. We have various services. So what we did, we wanted Rancher to just get it up and running super easy. So we bundled everything in one container. It comes up. It basically runs one Java process in there and a MySQL database, and it's all in that container. But what you can do is, instead of running MySQL, obviously, in that container, that's not the best thing. It is stored on a Docker volume, but instead what you can do is you can configure the container to point to an external database. So the ideal thing would be, use RDS or Cloud SQL and just, spin up the Rancher server and connect to it. Now, the ability to spin up multiple Rancher server containers and have failover and all that, we need to really write up some more documentation on how to do that. Because it gets a little bit more complicated because we have these services like the event bus and lock manager. When everything's in one container, it makes it really easy. But as soon as you have multiple, then you have to look at setting up those services. So we haven't done, really a good job in documenting that and how that works, but that is for sure, kind of within the beta timeframe of when we push Rancher out there, we'll have that ironed out. I mean, just to give you an idea of like our initial scale testing, we launched like over 100,000 containers using Rancher, and so we're pretty confident in kind of like the scalability of it. But again, not properly documented, and we need to do that.
Great, thanks. Two more questions, and we'll actually get to the demo. One, which is near and dear to my heart, Matthew just asked, Rancher and RancherOS are all open source, so how will Rancher Labs be profitable and stay afloat? Are there support or services we haven't covered that are the commercial side? Yeah, Matthew, great question, and certainly something that we're thinking about. Everything we're doing is open source, but at this point, we're very comfortable with the open source software model for building business. So, our team has done this before with with CloudStack and other things, and the real plan is we make everything available open source. The community uses it. We work on it. We improve it over time, and as the product matures and we get to a point where there's actually we're past the alpha stage, and then we'll offer supported versions and commercial versions for companies that need support from us or need help implementing it or maintaining it or managing it. So we'll always have everything be open source. It'll all be available to anybody who wants to use it. But if you want to if you want something beyond this, then like you need support, then we'll be there to do that. We'll also we're certainly looking at things like maybe hosting the service or doing other things like that. So we'll see how things go. But our real focus right now is just getting users, getting this thing to make sense for people, and making sure that we're building it in a way that adds value and gives people something to use it for. So thanks for the question, and yeah, it's definitely something we're thinking about. There was another question for you, Darren. This one's from Pedro Camacho, and the question was, if I add to my Rancher a new host in another OS, for example, CoreOS or CentOS, and the host has some containers that weren't created with Rancher's interface, are those containers collected and the Rancher interface updated, or do I have to create everything over again in Rancher? It's a great question. I think it's something you're gonna talk about a little bit. So you want to address sort of supporting stuff that was created outside of Rancher?
Where the monetization strategy might be near and dear to your heart, this is something that's near and dear to my heart. So this is basically kind of like the feature we're calling this is like native Docker integration. Like it's really, really important to us to be able, a user to go into a box and run a Docker run command from the command line, and that get like picked up by Rancher. We do additional orchestration to add in networking, service discovery, load balancing, whatever we need to. But we still give that ability that someone could launch from the command line. And so this does mean also, like if a container is running, we will see it and import it. So I will tell you this feature is not done. It's a relatively complex thing. Unfortunately, like I had a demo of this running, but it kind of blew up. I just did a meetup last week where we demoed this, where you could basically launch a container and say, I want Rancher networking through a label on the container, and we would add it in. So the feature is not there yet. It's coming shortly, again within like the next month, because we already have kind of the PRs out there for this. But this is like, it's really important to me that this feature works seamlessly, because we provide Rancher. It's this nice, we give a nice dashboard. There's a UI, there's an API and everything. But we know people have other tools. You want to use, some configuration management. You want to run Ansible scripts, or maybe you want to run Kubernetes, something like that. We want to be able to augment the existing Docker ecosystem, not wrap it and make it not possible for you to use these things. So this is something that we actually think is something kind of unique about the way we do orchestration in Rancher, is that we don't act as the system of record or like the authority on what the environment should be. It's kind of this cooperation between the orchestration engine in Rancher and what the user is doing on the box. And so we react to a lot of stuff.
Cool. Pedro, thanks for thanks for the help. So another question, this came from Charlie. He's kind of going back to Cloud Init and some of the RancherOS stuff, so I want to try and get it quickly in. He was asking, will you be adding or moving parameters to meta_data? For example, putting whatever artifact system Docker containers in there, or whatever affects system Docker containers in there, similar to CentOS Atomic or Fedora Cloud, or will you be going the CoreOS route where all your configuration parameters are in user data? Does that make sense? Question?
Oh, right. So yeah, we've gone the CoreOS approach where it's all in user data. So I mean, basically we're following that same approach because it's kind of like you have a single file. The metadata is kind of very, like you kind of first see that a cloud will support user data, and then maybe they support metadata. It's not always there. So so we are going towards, basically there's one key in the user data. If it's a cloud init, there's one key called Rancher, and then we're putting everything in there. If there's a particular downside to that, I would love to know it, because we are very flexible on these things, and if it doesn't make sense, we can change things.
Okay, so we're kind of cruising along, and sorry, Pedro had a follow-up question to his question about sort of native support for Docker. He was asking if since if he already has the systems up, until you have native support, could the solution be to put the images of containers in some registry and then import them again with the Rancher system? Would something like that work until we add the native support in?
Yeah, so I mean, until we add the native support, which really should come pretty soon, but until we add it, I mean, you basically need to delete the container and then redeploy it through Rancher. Unfortunately, we won't be able to kind of sync up what's in Rancher to the container that's already deployed there, because some of that tracking, it's like the logic of like we have like this container defined in Rancher and this is actually the container on the box. That logic of tracking those things properly is kind of in the newer development for the native Docker integration.
So a couple more questions. One was from David Tremblay. He asked, what's missing before the Rancher stack can be used in production?
Well, so the thing is, we're shooting for a beta, and the beta is basically like proper support for Compose, Swarm, Docker Machine, the native Docker integration, and then storage snapshots. Yeah, and so I think those are the 5 main features that we're shooting for. That we think that's a fairly feature-complete platform for production. Now, once we have those features, it is still in alpha beta state, so it's really hardening. We do at least pull on a lot of experience of writing these stacks in the past. The things we've done kind of in the cloud space with Cloud Stack and other things. So we're fairly confident that we have a good scalable platform. But for anyone who's ever tried to write something like, oh, it's going to scale to millions, you put it under load and it fails at 12. So I think really for me to say that this is really production worthy is that we've really stress tested it and ironed out some of the bugs.
On that topic too, guys, we are actively trying to find friendly partners who want to be early beta users, and the advantage of that is we work really closely with you. We have meetings, we talk feedback, we get your ideas on what's good, bad, or could be better about the system. So feel free. I'll send out my you should all have my email. I think everyone got a little note from me. So feel free to send me an email if you're interested in that, or shoot me a private message on the chat. We'd love to chat with you about that. A couple more questions. Oh boy, this is a tough one. Yeah, Ios, Pap. Is the service discovery pluggable? Can I choose to use etcd or console instead of whatever we're building? And just to be clear, this isn't even available yet. We're still kind of working on it. But do you want to talk about that, Darren?
Sure. Yeah. So so this is the thing that we're working on, and basically, supporting Docker and their interfaces and kind of their model of how to do things is really important to us. And so we're going down the same route as Docker, which is pretty much to go towards DNS-based service discovery. So you define service foo, and then when your container, you can just look up the DNS name foo, and it will resolve to the right IP. Now we know there's issues with DNS propagation and things like that, and those are some of the things that we kind of address in our implementation. But so the thing is when we talk about service discovery, it's largely based through DNS. So we don't have any intention right now of supporting like an HTTP API. If users say that's something they really want, then we can look at that. So from that perspective, it's kind of like, it doesn't really make sense that it's like pluggable with console or etcd or whatever, because the interface is just DNS. So right now it is basically just kind of our implementation of it, and we think that's relatively non-impactful. But we would absolutely love the feedback if you'd like to see something different.
Yeah, I know we've had a number of people who use console and etcd say, they would just continue using those things around what we're doing, and we could certainly, initially we're kind of looking at sort of keeping this all really simple. So it would be, we certainly love to find a way to do more with those tools as well. So definitely.
Yeah, and there's nothing that would prevent you from still running console or etcd or Zookeeper or one of those things.
So a couple more questions, and then we'll let you actually do the demo. Let me see. So first one is this one's from Christopher Jackson. He was just asking, is there a preferred host OS for running all this?
Not really. So for Rancher, we just need a good Docker host. So so that means we kind of gravitate towards Ubuntu, Fedora, RHEL 7. Trying to think.
It's got to be It's got to be Docker 1.4 or later, right? Isn't that the requirement?
Yeah, it's got to be Docker 1.5. Like we're always on bleeding edge, so I can tell you when Docker 1.6 comes out. Like within a week we'll put out a release of Rancher most likely, and we'll need 1.6 because we're actively putting in features, and so we need the latest. And so one of the things that happens is because we're bleeding edge right now, is like what's packaged in like RHEL 7 won't work with Rancher unless you manually upgrade to the latest, by doing the binary install. Now we know down the line, that's not feasible. A lot of people want to run RHEL and they want to run the RHEL supported version. So we will start supporting older ones, but just kind of at this alpha phase doesn't quite make sense to do that. So, to kind of sum that up, we don't necessarily have a preferred host OS. It's just what runs the latest Docker well. And we support all the graph drivers. I'm pretty sure even LXC exec driver works, although honestly not well tested.
The obviously we test with different things, but welcome to use RancherOS.
Yeah.
Here's another one. Brandon was actually asking, if we were running Rancher Agent on RancherOS, should that be a system or a user container?
That should really be a system, but it's a user container right now. And so we're actually, like as we were saying before, these two systems, like RancherOS and Rancher, are not really coupled together, like tightly coupled. And so we're actually kind of adding support to Rancher to kind of optimize it for RancherOS. So it would make sense for it to be a system container, and we would like to actually recognize that it's RancherOS and we have 2 Docker daemons and be able to manage the 2 Docker daemons. But we don't really have any of that support yet. And so right now when you deploy the Rancher agent on RancherOS, it actually goes as a user container because that's kind of how it works on everything else. So that will probably change over time, but that's what it is right now.
Okay, just to follow up, could Rancher Agent eventually enable users to update system-level containers? That was also an follow-up from Brandon.
Yes, very much so. And so because as we talked about, like the YAML documents, or sorry, the compose templates to say what services, we would imagine, down the line that we could manage that, and you could put policies around it. So you could basically say, okay, every single node in this environment needs to have Nagios, and so we would just automatically apply those system services. And so, yeah, we have every intention of managing that from the Rancher agent and from the Rancher portal and all that.
Okay, another question. This one is this kind of goes back a bit, but we talked about some of the stuff that's coming on the roadmap and adding more bare metal support into RancherOS. And Sign Off had asked, what is the bare metal support that is currently missing from RancherOS?
Yeah, so we don't have all the drivers compiled in, and there's some silly ones because we really just selected what we just needed to get it to boot on clouds, and so something as basic as USB is not even in 021. So if you have a USB keyboard, it won't work. But we have actually had quite a few people boot up RancherOS on bare metal, and they're running it. So basically, the main things that we're missing is more drivers, proper firmware loading. That wasn't actually happening properly. So if you have a NIC that needs a firmware, that wasn't working in the current release. Yeah, so that was mostly it. It was firmware, UDEV issues, and drivers.
That will certainly be as we move towards more of a beta point for RancherOS. That'll be some of what we had. Sign-Off had a couple other questions. One was, and I think they're kind of related. One was, can't we boot off USB ISO and install it onto the hard drive? And he also missed whether we could run RancherOS on a host without using a hypervisor. So, do you want to kind of cover this?
Yeah, and so the ISO is a hybrid USB disk, so you can just boot off the USB. And there is a command, RancherOS install, documented somewhere here, and it will install it to disk. Let's see, RancherOS install. Yeah, so there's a section here in the README of installing to disk. So you could install the disk and boot off of it. So this is how people have gotten RancherOS running on bare metal today. And yeah, we don't require a hypervisor. Just granted, we have the proper drivers for your bare metal. In fact, RancherOS actually works really well to be a hypervisor too. That's a whole different topic.
Okay, so I'm going to pause the questions there. There's a couple more questions about how Rancher compares with Kubernetes and what are the storage features of Rancher that maybe you can address while you go through a little demo. But seeing as we're 2 hours in, I think it'd be good to hit that demo, and then we can sort of start wrapping up.
So I'm going to go through a basic demo here. We could spend a lot of time on Rancher. It's really a kind of a massive product, and so I'm just going to go through some of the basics here. So what you see here on the screen is, you log in. I have some nodes registered here. So these are some nodes running out in, I think these are on GCE. That's where I deployed them. So we have support for projects. So right now I'm logged in with my GitHub account. I can go and create another project here. So you can see the hosts are different for this project. I can go manage projects, add another one here. So our project support's pretty, it was kind of I think it was our first draft at it. We're actually revamping this based on a lot of feedback of usability and stuff to make this even better, add in LDAP support, things like that. So there's a lot going on in this, but kind of what you can do right now is create a project associated with a GitHub team. I'm just going to cancel. I'm not actually going to create it right now. But so basic project support. Once you come in, you need to add a host. And I'm going to switch over to another screen here because this is a newer version. This is kind of what's on master right now. As you can see, we actually have DigitalOcean, Amazon, or custom. And so the DigitalOcean, let's see, why is that loading? Okay, so the DigitalOcean, this one's actually really straightforward, simple. You just put the access token, and a couple parameters like what image, and so this is all based off of Docker machine. And so this is one of the great things about plugging into kind of the Docker ecosystem is this really takes quite a bit of work to write all these drivers for all the various clouds, but all the clouds, kind of vendors are contributing and to Docker Machine to make it really easy to spin up these things in their clouds. And so we'll eventually add in every single provider. Right now we just pick some key ones. So you can see Amazon EC2. Amazon's a little more complicated and more parameters, but those are all the things of how Amazon works. But even if Docker Machine doesn't support your environment, this is some custom thing you've set up or whatever, you can always just run this command here, and it's just this big long Docker command. It has like a token in it, so it's secure and specific to your environment or your account. So you just copy that, run that one command on your Docker host, and then it will pop up in here. Let me go back over here. So this is just some basics here is like adding a container. So this is really a platform to manage Docker containers. Because of that, we don't really mask any options or anything. Every single option Docker can do, we try to expose it. If you see something that's not in here that you could do from Docker run, then it's most likely a bug and we just overlooked it, or we had some issue with it, but we should support everything. So you can see things like cap add, cap drop, device binding, some features that people don't even know about. Like we have support for all of these. So let me just go, and I'm just going to launch, let's see, an Ubuntu container here. Let's see. Okay, so that started up pretty quickly. And let me look at the. Sorry. So the container we're pulling in. Let's see, we're pulling in live stats. I guess there's probably not a lot interesting about just a running Ubuntu, but there's here. Let me show you the host stats. Those will probably show something a little more. So we're pulling in live stats from the host. Here's CPU utilization, memory, some disk stuff. There's actually significantly more. We're using CAdvisor right now to pull all of this. We're most likely going to switch to Docker stats because it seems to be about the same information. But once you have deployed, oops, sorry, let me go back here. Once you've deployed a container, you can do, like, one of the nice things is like you can just immediately drop into a shell for that container. So it's like here I can go and run top, like I'm just running bash in that container. You can view the logs, which is not really interesting for this container because it doesn't produce any logs. So that's the basics of launching a container. Now I'm going to show you some of the networking stuff. So you can say, like, let me create another one. I'll create Ubuntu too. So you can see in this environment here, like these IPs, this is the IP of the server, so 130, 231. So these are actual public IPs, given to us from Google. The IPs on the containers here, this is our own private IP space that we're running across our own IPsec-based network. So basically kind of running like a full mesh VPN across all the hosts. So when we do this, if everything worked right, this host here is, I should be able to log into this container and ping this IP. So 108.247. 247. Let's see. Hopefully everything worked. Yeah. Okay. So I was able to ping that container. So what's happening here is it looks like it's on the same network because it's our kind of our own virtual overlay network. So this works the same, if I'm in like the two machines are both in Google Cloud, or I have one machine in Google Cloud and one machine running on bare metal and software. It will work the same. So it doesn't really matter where the VM or our physical machine is. The containers will all be put on the same private network. So kind of going along with our private networking, we also have the ability to link across hosts. So if you do like networking here and you say link, I could link to, I don't know, I think this one was running on different hosts, like Ubuntu there, name it something. And so that will actually create a link that works across hosts. registries, this is this is probably the #1 requested feature, was that we support custom registries. And so if you have like your own like Play.io account, you can put whatever you want in here. And so when you deploy a container, so if I go and say add container, you can actually specify like that credential, that ASDF credential that I just created there. So you can specify which credential you want to use when you pull images. Okay. Okay. So the very last thing that I wanted to show to you was the compose support, and so this is like a very early version that we have running of this. Make sure this is the right environment. Okay. So here is a Docker compose template. This is kind of nonsense. It's not a real application, but would have been nice if it was. But so you can see various things, like we have a web one. This is Zookeeper, Redis, so various containers there. So basically what we're doing with our Docker Compose support is we're not actually using the Docker Compose binary itself. We're implementing a binary that just basically looks and behaves exactly the same. This is because we decided to implement a little bit more server-side logic with it, but we're supporting the standard template. The command line interface looks the same, so it's all we're still supporting the Docker interfaces, which is really important to us. Like whatever the Docker interface is, we'll always support that. So you can see here, this is a very simple demo of basically, so my Rancher Compose, my YAML file, and then I say up. So then I'll go and create, create these containers that are running across those hosts, and then it links them across hosts and everything. So that's
Darren, just to be clear, when you executed that command, you're executing against the Rancher API, correct?
Yeah. Well, so you run the command line binary, so you download that binary, and then that is actually hitting the Rancher API. So that's kind of like our, we have a very extensive API, but honestly we don't talk about it a lot because we really want to support the Docker native interfaces.
So that actually kind of brings up a question, two questions that were asked in the last couple minutes. One was directly on that. Andreas was asking whether, as Rancher scales to millions of containers, how are those deployed? And his hope was it was not in the UI, not in the web UI. So do you want to talk about sort of the different ways to provision and to manage, large-scale deployments?
Yeah. So, even though we have this really nice UI, we know it's completely impractical to go and click around to deploy things. So we really see the primary interface really being Compose. That's what we've seen. Kind of the most demand for is to support Compose templates, and so we're really looking at a perspective of how do we make Compose work in production, how do we do long-term maintenance of applications, so it's not just a dev tool of like up and then delete. So how do we do migrating the apps? So like let's say you have an older version of a template and a newer version, can we deploy, figure out the delta, upgrade, things like that. So we're working on that. So Compose is one approach that we see. The other is basically just running Docker run commands, which would be would most likely come through like a configuration management tool. And then the third approach is something like Mesosphere or Kubernetes. There is, kind of some overlapping things that we do or Docker does, or, all these projects kind of overlap a little bit, but a lot of them kind of have their sweet spot or whatever. And so for whatever reason, you might want to use Mesosphere or Marathon. And, so we will still support running Rancher under there. So like we can add networking, we can manage system services if it's RancherOS, or we could do some storage stuff. Our service discovery and all this stuff will actually should all still work in the context of another orchestration tool. And the way that works actually has a lot to do with labels and how we're designing things internally. Like one of the things we did in Docker 1.6 is we pushed forward the work on labels so that we can make it really easy for us to integrate with these other systems.
On that, actually, Andres had asked maybe about 5-10 minutes ago how Rancher compares to Kubernetes and what the relationship was there. Do you want to talk about that a little bit?
Yeah, I mean that's like because there's always a little bit of an overlap, and so it's like Rancher right now we do really quite a lot of things, but our primary interface, or primary things we're supporting is the Docker interfaces. So it kind of ends up what's the difference between between Swarm and Kubernetes, because in Rancher we're going to make Swarm work really well. We're going to manage Swarm, we're going to set it up and everything, and so there can be kind of an overlap there. So I think Kubernetes has like a certain way of doing applications, like they have a certain methodology, and so I think that ends up being kind of like one of the main differences between something like Swarm or Kubernetes. Kubernetes has pods and a replication controller and a certain way to describe applications, where Swarm is more towards Compose. So I mean, I can't really say it might end up being preference to a certain degree, which one's kind of the better interface or products, so that they do overlap a little bit. I don't know, Shannon, if you want to add anything else to that.
No, I think it's a good answer. It's not easy. I mean, at this point, Andreas, there's a lot of development going on in different directions, and a lot of projects start in one place and then they sort of extend in different areas. But I think I think you get the idea. You can use these things together. Ivan, who's actually on I'm on the Meetup. Ivan Mikushin did a big piece recently on running Kubernetes on RancherOS, and we've been looking at how to run Kubernetes within Rancher as well. So I think we certainly would like all this stuff to work really well together, but there is overlap in places, so it's not always clear how that would work. So it sounds like that answers your question. One other question that David had was, he sort of asked about auto-scaling policies. He said, I'm rather new to this, but can Rancher specify auto-scaling policies for containers or for components of a Compose script? So do you want to talk about auto-scaling and what we're thinking about there?
Yeah, and so when we look at Compose, we kind of, I've mentioned a couple times before, like our implementation of Compose, we decided to add some like more server-side, like orchestration concepts or whatever. And basically, there's the concept of a service, because in a Compose template, each one of those containers you're defining there is really, in fact, a service, and you can have X number of containers running to implement that service. And so when you look at that, it ends up looking a lot like an auto-scaling group. And so our service, the way our services work in Rancher, like as we're developing it, so again, this feature doesn't exist, but as we're developing it, our services look a lot like an auto-scaling group. Now, so we have the support for basically saying I want to run like X number of these, or I want to add another one, or remove one. What we don't have right now is the collect the metrics, set thresholds, respond to the threshold to then add another. So the approach that we're taking right now is we give the kind of the primitives to do auto scaling, but you'll probably initially you'll have to plug in a system that can do the monitoring and decision making of when to call the operation. And so, we would like to see like a nice integration with like CloudWatch and CloudMetrics to be able to do something like that. Down the line, I imagine we will probably implement something there or partner with someone. But the first phase is just to give you that building block, so you can very easily automate that yourself outside.
Thanks, Darren. One question. Roman had another question. He asked, what will the interactions be between launch containers and load balancers? Will there be ELB style attaching or container groups that auto-attach to ELBs? This bleeds into launching more containers to scale, which is left for the end user.
Okay, so the load balancer, so basically we have like kind of two approaches to load balancing the support. So the first is just manual, which is like, okay, I'm going to launch a load balancer. I want the load balancer containers to run on these 3 hosts, and I want it to load balance these containers. And so that's just static manual setup. The second approach is when we tie load balancing into Compose and Service Discovery. And so what you then do for that is you say, okay, I want a load balancer. I want to deploy the load balancer on this swarm cluster so we can get some scheduling capabilities. And then I want to load balance anything that provides service foo, which basically ends up being a label on the container. So when you start the container and it has a certain label on it, we detect and we see that label. That means that label needs to be added to the load balancer. So if you're familiar with Kubernetes, this is not very too far off from like their services and their selectors. So you can look at it, you basically have a load balancer that kind of has like a selector that looks for a certain label. As containers pop up with that label, we then automatically add them to the load balancer. So if you had a service, like so if I had a Compose template and I had a service, I could add 3 more containers to that service, but then the load balancer will see that I added 3 more, automatically added them in.
Okay. All right. So we are now well over 2 hours into this meetup. So hopefully we've covered a lot of interesting ground. It looks like I'm still got a couple more questions, so we can cover a couple things. Darren, was there anything more you wanted to demonstrate, or have you kind of covered everything you wanted to show in the UI?
Yeah. I mean, I think that's about all we're going to cover today. I mean, we can definitely do like a follow-up or another meetup.
Well, we certainly will do more. We certainly will do more of these, and this worked out well. I think we were able to answer a lot of questions. There were 2 more questions that came in, so if you have more questions, now is your chance. Fire them away. The first of these questions, one was from Andreas. He said, what does the access control to Rancher look like? Currently seems to be limited to requiring a GitHub account for login. So do you want to just talk about sort of access control and where we're going with that?
Right. So the access control, you're right. Right now it is tied to GitHub, and that was just basically our first implementation. This is an open source project. We figured, GitHub was a common thing that people would use. If you actually want to set up GitHub, I'll tell you, it's actually really, really simple to do. Let's see if this UI pops up. I don't know what it's doing. But having said that, when we go and talk to various companies, people, or whatever, the requests for Active Directory and LDAP come up immediately. And so the model of how we built GitHub is, GitHub is not actually deeply integrated into the system. We have like kind of our own account management, which we have our own accounts in Rancher, which you can then associate with some externally managed account. So that externally managed account today happens to be GitHub. Very soon we're going to add Active Directory and LDAP. So I mentioned before, like what you see with our projects and our GitHub support was kind of like our first draft. Honestly, it's after we putting it in front of users, we found out it's a little more confusing than we thought it was. So we're revamping that, and at the same time we'll be adding LDAP and Active Directory. So that's basically where it is. If there's other systems, someone would like to see, then let us know. We can look at them.
Back to our request for beta users too, especially Active Directory. It's always nice to work with someone on that because AD approaches tend to be very, very different. 2 more questions. Let's see. One was a question from Yaz. He said, so doing a recursive DNS query for service discovery, is that how we're approaching it? Did I get that right? Let me see.
Recursive?
Yeah, recursive DNS query for service discovery. So is that what we're doing?
Yeah, so just to kind of clarify the technical details of the DNS is basically what we'll be doing is running a DNS server on every single host, and then changing kind of like the routing of the DNS for the container to go to that DNS server. So we will locally resolve the first look at what's the DNS for for that container. Like, so if foo should resolve to some container I've defined as foo, then we do that. If that doesn't work, then we'll recursively call the kind of the upstream DNS, whatever you have configured. Yeah, so like the approach of Rancher is, I mean, basically what Rancher is doing is we're spinning up these DNS servers and then managing the state, or pushing the state between them to make sure that they have the proper DNS mappings.
Okay, last question, and this is from Umberto Valiente, and Umberto asks, what about security between applications or even between external applications to the cluster? Do you have any mechanism for generating binding and credentials automatically?
I don't know if I fully understand that question, because there's two levels of security. There's one, like what's the, well, I mean, there's a couple different things to look at, like what's the security of our agents and our management stack itself? What's the security of the network?
You know what? Why don't I unmute Umberto and let him ask? He can sort of clarify the question. Here, Umberto, you should be unmuted. Do you want to just ask the question?
Hello, can you hear me?
Yeah, I can hear you.
Yeah.
Go ahead.
Hi, how are you? Yes, it's just to know, for example, that you have two applications, or actually you have an application and a database, for example, that usually you need some credentials for authenticating the application to the database. Can you generate credentials automatically so you don't have to expose the credentials on a file, like for example a WordPress? With a database, you usually put the username, the password, the database. So I want to know if with Rancher there's any way that create the binding and the credentials automatically, so you don't have to be in a file, for example.
Right. Yeah, so it's a great question. So, if you look at Docker, there's been some work around defining, the concept of secrets and storing secrets and providing secrets to containers. So, I'll tell you, within kind of the scope of the current beta right now is we're not looking at doing anything in this realm, but it's kind of like the phase 2 that we want to do something. And basically the approach that we've been thinking about is that you do create credentials, like Rancher manages credentials for you, and then containers you then specify what credentials it needs, and then on boot we'll put the credentials as a file in a temp.fs in that container. So it won't be an environment variable, it'll actually be an in temp.fs. So that's the approach that we're thinking, but I don't have a specific time frame on when we'll be implementing that. And it also largely has to do with what's the direction of Docker, because they had a couple PRs, they didn't really go anywhere. So we'll probably circle around and start the discussion again to make sure that if we're going to implement something that is kind of on the right track of where Docker's going to manage that stuff too.
Okay, one last question, and thanks, Umberto, for speaking up. One last question was just a validation on where to find the installer. I think someone had asked if it was on Ivan's imcushion / RancherOS installer, or if it was actually the one on GitHub, RancherIO. So do you want to just sort of show where that is?
Right. So if you want to run the installer like RancherOS install, basically you would be downloading the ISO and booting off of the ISO, and it's bundled in there. So you don't have to download the installer separately. If you poke around our GitHub, you will find this this one image called OS installer, and I think Ivan's contributed to this. This is kind of what we use internally. So it's like using this container directly. It can be like running with scissors. So we use this container internally to do something. So it's not really intended to be like the user visible thing. The primary way of doing the install is actually to boot RancherOS and run the RancherOS install command, which is bundled in the OS.
Okay, I think we've made it, guys. That was really fun. I hope everyone enjoyed it all as much as I did, and hopefully Darren isn't too tired. It's very, very early in the morning, I guess late in the evening, I should say, in in England. But hopefully we've answered lots of questions, and we've given you guys a good overview of sort of what what we're working on here. As I mentioned before, and I know a lot of people were sending out stuff on Twitter. Please feel free to shoot out a little bit of information about what you thought of today's meetup, and I'll try to get as many people as I can. The first few T-shirts, so we'll be sending those out. Getting started. The best place to get started on all things RancherOS and Rancher is in GitHub, so feel free to jump in. We'll be having these regularly. We're really the project's moving pretty fast. I mean, every week we're blogging about a new feature, or we're showing, recording a video. So if you go to our website, you can register for our newsletter, or sign up to our RSS feed on the blog, or just kind of watch the GitHub projects. I mean, all those are great ways to sort of stay up to speed on what we're doing. We'll be we're looking for beta partners, and we'll be doing a lot more to get this out there over the next few months. We're also attending lots of meetups all over the country and the world, and lots of upcoming conferences. We'll be at DockerCon this year, and others, OzCon. So if you have if you're able to get to a place we're attending, please come by, say hi, and introduce yourself in person. We'd love to meet you. Otherwise, thanks so much for your time, and please don't hesitate to send us a note if you need any other help through any of these different channels. Thank you so much. Have a great day, and thanks, Darren.
Yeah, thank you.